Okay, so welcome back. This is part 4 in our series where we're going to help you put together a C++ application. We're going to be using Visual Studio, and it allows you to do ray tracing using your GPUs. And we're looking at using CUDA. And again, we're doing this in Visual Studio. And in the previous videos in the series, we showed you how to set that up, and we show you how, in this case, I'm using my 2 GPUs and I'm rendering this very complex image, which has depth of field, it has shadows, it has reflections, it has glass, different colored materials. And this whole thing took only about 2.5 seconds on my GPUs using CUDA. So in the previous videos, we showed you how to set all that up in Visual Studio. And we rendered out this image. Initially, we rendered out the image to a PPM image file. And then in the last video, we showed you how to then render that to a window using SDL. And we also showed you in the previous video how to take advantage of SDL's event capturing functionality to do things like flipping the image in SDL. So I encourage you to look at those previous videos in the series. What we're going to do in this video is we're going to kind of step back and look at the code and kind of do a little bit of cleanup on some stuff. We basically downloaded and copied and pasted, and we've got this fairly simple application here with a bunch of header files. So I am a big believer that it's really bad to just copy and paste code and not know what's going on. Sometimes you have to do that, but in this case it's fairly simple. So we're going to take a look at the code that we're using and try to dissect it and see what's going on with CUDA and with the vec3 class, and we're going to see what's behind all of this, so then we can start to move forward from a basis of knowing what's going on. So here we've got our application. I'm going to close it. What we're going to do first is we're going to, if you look in, for example, one of our header files, ray.h, you can see we've got this pragma once, but we've also got these if-and-defs, and it's got an if-and-def with array h and then end-if. Since we've got pragma once, we don't need these if-and-defs. We don't need these defined. So one thing we can do is delete all of the if-and-defs and end-ifs and just leave pragma once. That basically makes sure that you only include a header file once. What I've done is I've gone through all the header files where we got the if-and-defs and removed them and just left the pragma once. So another thing we might want to do, and one thing that I do, is, as I mentioned previously, when you're doing CUDA in Visual Studio, you might get a bunch of errors, but at the end of the day, the errors were basically just IntelliSense errors that didn't affect your ability to build the application. It built fine, but you get these errors. For example, if I look at this code that we've generated, we've got a bunch of errors, or what appear to be errors, but if we run it, it works fine. And one thing you can do to get rid of that, we showed some other stuff before, like make sure you've got the correct includes. But one thing you can do is here, if you go into the error list with all this, expected and expression, blah, 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 note over here in the middle, we're asking for the build plus the IntelliSense output. What I do is I say build only. And generally that will help to get rid of a bunch of the errors and leave you with only the important stuff. So now the next thing I want to do is take a look at some of these header files that are doing the ray tracing and see what's going on and how the CUDA code is affecting that, and kind of dissect it to make sure we understand. Now we're going to start with the vec3.h because this is one of the crucial parts of all this code. You use the vec3s a lot for XYZ coordinates for a vector, and you also use a vec3 for colors, right? RGB. Let's take a look at this vec3, and ultimately what I want to do is I want to bring this vec3 code out into a separate application, a separate solution, and play with it a little bit, which I think is really important, so you get a feel for actually what the functionality is in this vec3 class and how it works, and If you make a separate solution, it's kind of a sandbox where you can play with it and see what's available, and that should help out a lot. So the vec3.h class, you can see it's including some header files, and it's got some constructors, and it's got some functions here. So what we're going to do is I'm going to copy all of this code in this vec3.h and start up a new solution with a vec3.h header file and also with a main.cpp, and then we can go into the main.cpp and play with the vec3 to see what it does. So now I'm going to create a new empty C++ project. We're not going to do any CUDA right now. We're just going to focus on the vec3 class and start a new empty project in C++. And once you got that, you're going to see kind of an empty project. And what I'm going to do is I have added a main.cpp. So I just take I've named it vectors test delete project because I can delete it later. And right click, and as we did before, add new item. And we will add a main.cpp, and then we'll add a vec3.h. Okay, pretty straightforward. So as you can see here, I've already done that. I've got my main.cpp and I've got my vec3.h. Here's the vec3.h. I just copied and pasted from the existing vec3.h in our CUDA solution, and that's about it. So now you may have noticed back in the CUDA code that we copied from, these host and device declarations here in front of all of the code. That's basically a CUDA thing we'll talk about a little bit later. But what I'm going to do is, to make it a little bit easier in our separate vec3 solution, I'm going to just delete everything that says host or device. So we just scroll down here and we can delete all of these, host, device. And then anytime you see over here, you see a device here, just delete that. Delete all these devices and all of these host devices. And you can see all of these have host device, so just delete those. And that will clean things up so we don't get annoyed by these CUDA parameters. The other thing we're going to want to do is comment out this CUDA device launch parameters.h. Otherwise, we should be all set to go and we can focus on the vec3 class. So now we're back in our new vec3 solution. We've erased all the device and host references. And if you look through this, you can see we've got a vec3 class in this vec3.h. And you can scroll through here and you can see we've got, here's the end of the class definition right here. And then we've got a bunch of functions that do a bunch of stuff. And if you think about it, well, we're going to need the vec3 class to do, well, stuff like math operations on vectors, like cross product and dot product and that kind of stuff. So we can expect that when we look through this vec3 class. But if you look at this, you might see some stuff that might be a little bit head scratching. Why do they include this? And if you look up here, we've got, I added some comments for the constructor. And also we've got these getters, which basically return some XYZ or RGB values. But you look in here and you can see these words inline, float, and const. And you might be thinking, why are they using inline, float, and const? Well, keep in mind this is designed to be a GPU, high-speed, very efficient application. So most of this stuff that they have here that you might consider extra is designed to make your application more efficient and faster. So for example, inline, what does inline do? Normally, for example, if you have a function or a method, the idea is if I want to call that method, I have a call and then I jump in code to that method, go through the code in the method and then come back. What inline does is when you want to call a method, instead of jumping to that method, you basically copy and paste the code of the contents of the method into the code at the point that you're calling. So basically every time you call the method, you're not jumping to the method, you are copying and pasting the contents of the method or function and going through those lines of code directly without jumping. So you can imagine if you call your method 100 times, you've basically got 100 copies of that method code, the contents of the method, added to your code. So you don't take time to jump, but you get a lot more code in your application. But it's a way to make things go a little bit faster. Also with the float, it turns out that instead of using doubles, if you can use a float, things are a little bit faster. Const also might help to speed things up if you define things as constants. So a lot of this stuff is kind of for optimizing and getting things to work a little bit faster. So now if we look here at the beginning of the class definition, we've got public, we've got a couple constructors. And you can feed it to E0, E1, E2, which are all floats. And it will assign those values to an internal array of floats. And you can see down here, float E is an array of 3 values, 3 floats. So once we've got that constructor, we've got these 6 getters. And basically what they allow you to do is to, when you've got your vector, you can get the X, Y, and Z values, but you can also make believe that there are G and B values, because really this is just a vector of 3 values. It doesn't care how you treat it. Unfortunately, you can also make some mistakes with that by adding vectors and colors, for example, but it's kind of an all-purpose vector of 3 values. So you can use X, Y, Z, you can refer to it as RGB, and it returns the same thing, the array values 0, 1, and 2. So these are just the getters to get parts of, or get values of the vector. And then we've got some other stuff we'll talk about in a bit. We've got, you can get the length of a vector, and it will calculate the length of whatever vector. You can get the squared length. You can convert a vector into a unit vector with values from 0 to 1. So we'll talk about that in a bit, but first we're going to talk about these functions here. And I'm going to pass through here, and here we've got something you might expect, functions to add, subtract, multiply, and divide 2 vec3s. Okay, I added this comment here, but basically we're saying we've got this operator plus, so you can feed it a vec3 and another vec3, and it will add those 2 vectors by having an operator overload of vec3s. And basically all it does, it returns E0 of first vector, or the X value of the first vector, and the X value of the second vector, and then the Y value and the Y value, and so on. So these are really pretty straightforward. You got the plus, minus, multiply, and divide for 2 vectors. Here you've got a few functions that allow you to work with a vector and a float. So if I want to multiply a vector times a float, I can use this operator. I can take a float and a vector, and it will basically just multiply the float by each value in the vector. Same with the divide. It will divide each value of the vector by the float. And it will also allow you to specify the vector first and then the float, but it does exactly the same thing. Now, here we've got 2 functions that you might expect to be very important: the dot product of 2 vectors and the cross product of 2 vectors. Okay, so here you say dot, and it basically takes 2 vectors, and the way you can solve the dot product is by basically, if you got 2 vec3s, you basically multiply the X value of both vectors and add that to the Y value multiplied of both vectors, and then multiply the Z value of both vectors and add that together, and that will give you the dot product. And as you know, dot product is basically AB cosine theta. It's a float. It's a value, not a vector. And then we've got the cross product, which returns a vec3, and it goes through this mathematics to obtain the cross product. So pretty straightforward. Basically add, subtract, multiply, and divide, and then cross product and dot product. So now let's jump over to the main.cpp that I added. And here is the code I added just to get us up and running and seeing what's going on. Make sure you have include vec3.h, which we already talked about. Also, we're going to include IO stream so we can print to the console and see some stuff going on. And here I've added int main, and I've defined it here. And what I'm doing is I am instantiating two vec3 objects. One is called origin, one's called direction. And I'm just arbitrarily saying origin is a vec3 of XYZ value of 2, 3, 4, and direction is 5, 6, 7. So that's kind of how you define a vec3. And what I can do is I can now do a dot product, and I can use the dot product functionality, which is called dot that we looked at before, and I just feed it the origin vector, the direction vector, and it gives me a float, and I'm going to call it dot product. So we can figure out what that answer is going to be and see if that's what we get in the console. We said before, dot product for two vectors, basically you multiply these two, the x values, so we get 10 plus 3 times 6 is 18, which is 28, and then 4 times 7 is 28, so 28 plus 28 is 56. So we expect the dot product value to be 56, pretty straightforward. And then cross product, we'll see what the cross product is, a little bit more math there. And then we can subtract the vectors. We can see that we have now an operator for the subtraction of two vectors. We're overloading this operator, and we're getting a vec3 called subtraction. Also, keep in mind one thing about Visual Studio that's so nice. We can say vec3 vector 1 equals origin dot, and you can see it's got a list of all the functions that are available to us. We can assign a blue value or an E, which is the vector itself. We've got a green value. We can get the length. We can convert that to a unit vector. We have all these operators: times equal, plus, plus equal, minus, minus equal, divide equal. An array, we got the R value, the squared length, X, Y, Z. It's an easy way to look at all the functions available to you from the vec3 class. So now I'm going to delete that, and we're going to run this and see what we get for the, we're going to print out the dot product, the cross product, and subtract the two vectors and see what we get. And you can see, as we said, the dot product is 56. Multiply these and add. The cross product is minus 3, 6, and minus 3. And if we subtract these vectors, you can verify here 5 minus 2 is 3, 6 minus 3 is 3, and 7 minus 4 is 3. So I encourage you to go through with this vec3.h and also the other header files, maybe make a separate solution and start playing with them and seeing what functionality they have, and can really help you better understand. Now, I think in the next video we'll start to go into CUDA. In the meantime, I wanted to give a couple recommendations for really good sources if you want to learn ray tracing. It's really a very complex subject, so you really need to study it. But there is a really good website called scratchapixel.com. It's been around for years, and they really got some great visual, conceptual understandings. Scratchapixel.com, and you can see they've got 3D rendering. They've also got geometry, inverses. They've got a whole lot of stuff, and they lead you through the different concepts associated with ray tracing. Absolutely wonderful, wonderful website. Again, it's been around for years, and it's a really great go-to place if you want to understand stuff. Now, another thing I want to recommend, if you really want to get deep into coding ray tracing and you want to see how the really professionals do it, Blender is open source. So you can actually look at the code on how they do ray tracing, how they do basically anything you can imagine as part of Blender. And if you've ever used Blender, you know it's got incredible functionality. So if you go to developer.blender.org, you can find any part of the code of Blender, and it's really wonderful. And I also encourage you, I've got a series on 3D computer graphics, and using Blender to make stuff. You really, if you're going to do 3D graphics, you got to get something like Blender and actually do it yourself. Figure out how it works in the real world, and then doing the code is a lot easier because you can have a visual idea of what's actually going on in a real ray tracer. and you can work back from that, and you can look at the Blender code for like cycles, the Raytracer there. So really it's got an incredible amount of functionality, and I really encourage you to look at the different codes. So for example, you can go to cycles and you can click on that, and it's just like a GitHub repository. You've got the source code, and you can look at BVH, the application. So you've got all of this stuff that you can look at the actual code and see how it's done. So I really encourage you to consider that. Now, one source that I saw a C++ programmer recently recommend is this book called Physically Based Rendering from Theory to Implementation. And again, it's been around for years. I bought this book about 4 years ago, and honestly, it has been sitting on my shelf for all those years. It's a really amazing piece of work. However, I found it to be basically of little use. And the reason is because it's 1,000 pages and it's 99% equations. And I've been an electrical engineer 45 years. Equations are fine, but unless I really understand the concepts behind it, it can be a real pain, especially in a book like this where they have their own symbols for different things. You don't know whether they're talking about a vector, vec3. It can be really, really confusing to try and go through this. And I've tried, and it's really very difficult. The other thing is they have this concept called literate programming in this book. And it's trying to make things easier, but in my view, it makes things worse. It's kind of like if you've ever done programming, you're familiar with pseudocode, which is kind of an English representation of what the code's going to be. And they have kind of a variation on that, and I've never quite gotten my head around what they're doing. I know they're trying to make it easier. Yeah, it's fine. You can try this. In fact, you don't have to buy the book. You can go online. Full contents are freely available if you go to pbrt.org. The full contents are available for the 3rd edition, the latest edition. And you can go through, and here's all the 1,000 pages worth of stuff. And feel free to look at it if it's useful to you. To me, not so much. So anyway, that's about it for this. I think in the next video, we'll probably start to get into CUDA, talk about what this global and host and device are, and maybe get into CUDA a little bit. And we gave some references on how you can start getting into CUDA. I encourage you to try some of that on your own. Otherwise, if you like any of these videos, I encourage you to hit the like button, subscribe, hit the bell notifications, and most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.